So the point is that decision theory has done precisely, it's in some sense just the opposite of psychometric theory. It focuses primarily on behavior. It seeks to identify systematic patterns in behavior that hold across a variety of contexts. And so what I'm going to do today, I'm going to show you how some insights from decision theory about some testing issues. So when you're answering a multiple choice test, which is by far the most popular format of test, and by the way, for those of you who don't know, this is all started during World War I when the Army was administering the so-called Army Alpha and Army Beta test, because they had, with technology of 1910, to test large amounts of people, and there was no way to test people individually, and therefore they came up with this idea of a multiple choice that's easy to administer and easy to score. And so essentially what the test taker is facing a decision making under uncertainty, just like the commodity, the trader who needs to decide whether the cotton goes up and down. And the test taker either knows or he does not know the answer, but very often he or she is going to be in this gray area of partial knowledge, and that's where many of the interesting decisions are going to take part. So the choice that the test taker is making is based on that state, whether he or she knows or does not, or has partial knowledge, on his or her perception of what will be the outcomes if you answer correctly or incorrectly, and of course, what are the test taker's ultimate goals. And so whenever you analyze test-taking behavior, you should think of all these components, but my claim today is that psychometric theory fails to consider all these components, and quite often it invokes, in the service of coming up with nice model, a variety of assumptions that are unrealistic, somewhat naive, and in some cases patently false. And what's the worst part of this is that some of them are self-defeating in the sense that instead of improving the quality of measurement, they are going to reduce the quality of measurement. So I'm going to now go through through 4 examples. I'm going to describe them at different levels of detail. So first one is, how many options should an item have? Should an item be in a test a true, false, namely 2 options, or 3, or 4, or 5, or 6, and so on? Well, psychometric theory has answered this question in a variety of papers, and by using several criteria. For example, you want to have a test that is the most valid that's possible, or that discriminates as well as possible between test takers and so on. And all these solutions end up with pointing to a relatively small number of options, around 3. I say, by the way, around 3 because, interestingly, one of the solutions is that the number of options should be the transcendental number E, 2.78. But it's difficult to write 2.78 options, and so we round to 3. Now, all these solutions have a common assumption. Namely, they assume that when the test taker is facing the test, there's a fixed amount of time, say 25 minutes allocated to this particular test. You can proportionally increase the number of items and reduce the options, and vice versa. So you can have 8 items with 4 options, or 4 items with 8 options each, and the effect is going to be the same. And then what they do the calculations of what will be optimal in the psychometric sense under these assumptions. And I never believed this assumption. It always struck me as being funny. So we ran a very, very nice experiment, if I may say so myself. We started with a test that in its original form had 5 options for each item. And then we took away 1 and we created one with 4. And we took another one, we created then one with 3 and one with 2. And in fact, we do this in various ways because if you can, out of 5, you can begin to take things in various ways. And then what we did, since we wanted to look at proportionality, we did 2 things. First of all, we had a fixed amount of time, so we knew when the test was over exactly how many items everyone completed. And in addition, at various times during the test, after 5 minutes or 10 minutes and so on, we asked the participants to mark exactly where they were. So we knew how many items they completed in the first 5, the next 5 minutes, and so on. So we could use this data to analyze whether indeed this idea of comparing across all these tests, whether this idea of proportionality holds. And in fact, it doesn't. because it turns out that a much, much correct way to describe this process is that, in fact, for different types of items, different types of tests, of abilities, according to the level of complexity, people end up spending more time, differential time on items. And in particular, they end up spending more time on things more complex, such as mathematics and so on. So the bottom line of this is that if you then redo the calculations under the revised model, I'm going to save you all the technical details, under the revised model, it turns out that under a more realistic test, under a more realistic setting, the test will be more reliable, more precise, more accurate if in fact you have more, 5, 6 options and so on. So that was the first example, which is not very exciting. The second one is really fun. I mean, you may not like my lecture, and you may say I wasted an hour of my life. But there's going to be two things that you can take away from this lecture. There's going to be two practical recommendations that would serve you or anyone in your family or friends who needs to take a multiple choice test. And one is going to be in this one, and the next one in the last example. So, to guess or not to guess. So the idea is really very simple. Fred Lord, one of the top 3 psychometricians, if you're going to do ratings, wrote a nice paper in 1975 where the motto of the paper is that reasonable people disagree with great assurance on certain things, such as religion, politics, and, of course, formula scoring. Formula scoring, also known as the correction for guessing, is this idea that people knew from when the Army Alpha and Beta started that you can get an item right simply by guessing, so you can get the right answer without knowing why it is right. And people have always been concerned about this possibility, and they seek ways to correct for guessing. So to minimize bias and to reduce errors and so on. And so how do they do that? So the standard way of scoring a test is very, very simple. For every item, if you get it right, you get 1 point. If you get it wrong, 0. And if you don't, if you skip it, again 0. And then your score is simply the number of items that you answered right. And in 1919, another of the top 3 psychometricians, Leon Thurston, wrote a paper in which he proposed the following alternative scoring rule. You get an item, if you write, you get 1 point. If you skip, omit the item, 0. But if you get wrong, we're going to impose a penalty. The penalty is going to be of the magnitude of 1 over a minus 1, where a is the number of options. So if it's 4 options, the penalty is 1/3 point. So deduct 1/3 from your score. So the final score is how many you got right minus how many you got wrong divided by 3. Now, where did he come up with the a minus 1 rather than any other value? It turns out that you have to come up with a psychological model about the test taker to justify this particular solution. And the model says as follows. Some people know, and if they know the answer, they answer correctly for sure. Other people have no idea. It's if it's a test in a foreign language. And therefore, they, so to speak, toss their proverbial mental coins in their heads, and randomly, with equal probability, they say A, B, C, or D. Okay? And then, if that's the correct model, then the algebra follows that by penalizing by 1/3, you are basically taking away exactly what is due to guessing, no more nor less. So what's wrong with this formula, which is being used, by the way, as far as I know, it's used today in the SAT. First of all, this model is patently false because it basically dismisses the possibility that people have partial knowledge because it only recognizes perfect knowledge or absolutely no knowledge. So clearly that's a major problem. Secondly, it assumes that people can tell correctly what they know and how well they know, when in fact decision theory has lots and lots of data that has shown over the years that in fact people are very, very miscalibrated. So this is a graph I need to explain. This is a graph from a paper that Tom Walston and I did a few years ago, and the experiment here was the following. We presented subjects with statements about pairs of American cities. For example, in 1990, Cleveland had a larger population than Cincinnati. And the subject was supposed to tell what's the probability that this statement was correct. Or, in 1990, Los Angeles was more populous than Oklahoma City. What's the probability? And so on. And what we are doing here, we are showing all these responses. So for example, these are the cases where the people say they're 80% sure that the statement is true. And what you can, if you look at on the y-axis, you'll see in how many cases when they said 80%, they're actually true. And what this graph shows is that people are relatively good in the middle, around 0.5. They are quite accurate there. They are calibrated there. But they are misjudging quite severely near the ends. So when they say they are sure it's true, they're actually right about 80%. When they are sure it's false, they are right. They're also right 20%. So in other words, people are very, very bad at judging their own state of knowledge, and especially about things which are in the extreme. Therefore, you can certainly cannot expect them to judge correctly and to diagnose when they know for sure or whether they know. There are a couple of other things that are wrong with this theory. One, it's very, very difficult to make items where all the options are equally attractive. And second, people have a hard time guessing randomly with equal probabilities. Even if they try, it will be a very, very hard job. So one notorious problem in doing that is that people have this curious bias of avoiding the edges. So you can do the following guaranteed to work and entertain exercise in your class. You tell the class, we're going to put together a multiple choice test on, you name it. So next week, everyone brings in 2 items, multiple choice, and with 4 options, 1 correct and 3 incorrect. And you collect then from 50 or 60 people the items, and you see where everyone placed the correct answer. And the answer is going to be about 70 to 75% are going to be B or C, and only about 25% are going to be on the edges. So this phenomenon, kind of middle bias or edge aversion, certainly goes against this idea of random guessing. And there's also evidence that people cannot follow the strategic implication of this formula for guessing. How do we know that? We can run the following very simple experiment. You go into a class, administer a multiple choice test with admonitions about guessing and about the formula scoring. And then, when the test is over, you go around and instead of collecting the test, you collect the pens, give everyone a pen of a different color, let's say red, and ask them, everyone to mark all the items which they omitted because they saw they didn't know and they didn't want to be penalized. And then you can score the test in 2 different ways. Once according to scoring formula, and once against the full answers. And invariably, you see that people are hurt by this formula because they tend to omit and not to answer enough because they don't have the right sense of their own knowledge. So, how do we deal with this problem of the strategy? Well, I'm not here to criticize ETS or the College Board, but it's just too easy. I really like that. So I went last week on their website, and these are not the instructions from the test, but this is what they tell to people who are considering applying to take the SAT. That's their strategic advice. Make educated guesses. If you can rule out 1 or more answer choices, you have a better chance of getting the right answer. Then the second advice is skip questions that you really cannot answer. Why? Because no points are deducted if an answer is left blank. Okay? So I have a problem with this advice. It is partially incomplete, and in some sense it is wrong, and in another sense it is imposing on people certain values or certain attitudes which they may or may not have.